My dear learners, including age group 6 years to the age of our grandfathers, age is just a number. This is part 2 of operators in Python. So let's get started. Let us see what are identity operators. We are having two identity operators, is and is not. Now the identity operators check whether two variables share the same memory location, right? It doesn't check whether they are equal, right? Let me illustrate this through an example. Suppose I'm having a equals to 10 and b equals to 10, right? Now, if I write a is b, is will check whether a and b share the same memory location or not, right? Let me run it. It's saying true. This means a and b refer to the same memory location with different names, right? Even we can check the memory location, right? Print id, id is the function, right? Comma id b, right? So you can see both of them, they share the same piece of memory, right? Okay, and even if I write a equal b, right? A equal to b, then that also comes out to be true because the values equal to double equals to checks whether the variables contain the same value. It doesn't check about the memory location, right? And is checks whether this share the same memory location or not, right? So now if I take a equals to, now I am making a list data type, right? I know you don't know about the list data type, but for illustrating this identity operators, I'm taking it, right? So we take a square bracket and we put this 10 in this. This is a list, right? And similarly, b equals to square bracket 10, right? And now if I check first a equal to b, this comes out to be true because they have the same value. But now if I check a is b, now see the guys, it's coming out to be false. This means when I create a list, they share different memory locations, right? And it also clears out the difference between equal, double equal to, and is. Now what is the working of is not? It is the reverse of is. It checks whether a is not b. If a and b do not share the same memory location, it will return true. So it returns me true. Okay, and if here I do a is not b, that is a is not b. Okay, so it comes out to be false, right? So it's very easy, you must have understood. Moving on, let us see membership operators. So we are having two membership operators, in and not in. Now what do? They check whether a certain value is present in a sequence of values or not, right? So to illustrate this, I would have to create a data structure list, right? I know I've not taught this, but I'll explain to you what is a list in simple terms, right? We will be covering this in detail in further videos, right? List. So I create a equals to, now why I'm creating a list? Because list contains a sequence of values. It is like a list of values. Okay, so I'll take 10, 20, 30, 40, right? Nothing very complicated, it's very simple, right? And for checking, I'll take b equals to 40 and I'll check whether a has the value b, and I'll check it by using b in a. Very simple to understand the syntax also, right? Whether b is in a, and I get it as true, right? But if I would have taken, suppose b as 6, right? False, right? B is not present in A, right? And if I take not in will check whether B is not present in A. And if it is not present, it will return me true. And that's what you see, right? Now, guys, let us see bitwise operators. So, bitwise operators are your and, this is and, this is known as or, this is XOR, this is not, right? This is left shift, left shift, and this is right shift. So basically, bitwise operators are used for comparison of binary numbers or say operations with binary numbers. You know, any number, 8, any integer, any number can be written in 0 1 1 0 1 format, the language of the computer, right? And you'll hardly create any program or hardly write any code where you will be using these operators. I'm not saying they are not important, right? They are, but hardly any code will write. Right? These are basically used for faster processing of the program because the language of the computer is 0 1 binary. And if we do binary operations, it will be easier for the machine to process it, right? So we hardly require this actually right now in our domain, right? And it's hardly used, okay? It may be used when you are doing some competitive programming, but in data science, at the moment, I don't think it's required. So if it will be required, I'll create a video on this bitwise operators and this bits operation. Let us see assignment operators, right? So what are assignment operators? These operators assign some value to a variable. So suppose I am taking x, so equal to, this equal to is also an assignment operator, right? And all the assignment operators are made from equal to only. Equal to, we know x equal to 8. So x is assigned with a value of 8, right? But how does this plus equal to, minus equal to, multiply equal to, divide equal to, floor division equal to, how do these work? Let us see. If I write x plus equal to, let us say I write 9, right? And if I try to print x, I'm getting it as 17. Writing this x plus equal to 9 is same as writing x equals to x plus 9. Okay, I would have to do, okay, x equal to 8 default because the value has changed to 9. And now if I print x, I'm getting 17. So this x plus equal to means x equal to x plus 9. Similarly, guys, if you write x minus equal to, sorry, minus equal to 9 minus 1, and I am making the change here also minus 1. And all of these, right? These are the arithmetic operators. You can see plus, minus, into, divide, floor division, exponentiation, and modulo. And the other are the bitwise operators, okay? Excluding our not operator, right? So all of these when combined with equal to do these kind of operations. Okay, right? So we have covered all the operators in Python, leaving the bitwise operators, which I think are not of any use at the present, right?
पूरा इंडिया पढ़ेगा डेटा साइंस. Ready for my next video? So goodbye and namaskar. Please like, share, comment and subscribe to my YouTube channel. Don't forget to press the bell icon.